Hello guys, today I'm going to talk about the basic concept of the span tree. In the video, I'm not going to talk about the PVST, OSTP, MSTP, and the concept of the state of pods, role of the pod. No, I'm not going to talk about that. What I'm doing for this is that I just want to talk about why do we need the span tree. So what if we eliminate the span tree in our production network? What happened? Okay, so in this video I'm going to demo you about this. Okay, so let's start with our topology. I got 3 switches. Okay, so I just connect them with a random port. Alright, so let's see what going to happen next. Okay, as you can see that every switches has the amber port here. It's mean that orange color here. Actually, in the packet tracer, they allow you to see this, but in the real switch, you cannot see like this. We have to go to the switch and show commands, something like that. But in packet tracer, you have to learn how to watch this port. Okay, so we can see the amber port here. So it's mean that it's doing the convergence, is calculating the algorithm, which one should be the forwarding port and which one should be the blocking port, something like that. Okay, as you can see that after a few minutes, it's around 50 seconds. As you can see that every port is in the green port, and only this port is in the I can say still the orange. Okay, orange port. So it means that this port is blocked. So why? Okay, let me explain you in the process. So first of all, like laptop 0 here want to send the packets to the laptop 1 here. Okay, it cannot send directly like this. What I need to do with that, it is to send the packets to the switch here, like it to it. Okay, and the switch here is going to do the broadcast flat that packets to first of all, like suppose that every switch has the MAC address table. Okay, MAC address table. Okay, it's empty. So it's empty for the first boot up. So if it learn MAC address table on every switch, is this another story. Okay, so make sure that MAC address is empty, so it's going to process like what I'm saying right now. Okay, so again, so first of all, laptop 0 sending to the switch here, and the switch here have no idea what the MAC address of the laptop 1 here, and going to how can I say, floods the packets. Okay, to find the MAC address. So I'm going to flood to the switch 0 here. Okay, it also flood to this port, but this port is blocked, so it cannot flood. So that's why this port is okay. It cannot send the traffic to this port, only to the FA0/1 here. Okay, and the switch 0 here, it's going to see the packet. It doesn't know where to get the MAC address. It's going to flood again to the switch 2. Okay, it doesn't flood back because the rule is that it only flood to every port, but not the port that it get the packet. Okay, so it's going to flood only to this port, right? And then the switch going to flood the packet to this laptop 1 and to this port, but this port is blocked, so it will not receive to the switch 1. Okay, and then what is gonna reply like that? This PC say, okay, here's the MAC address of me, and go reply back to the switch. This is why I'm going to do the broadcast again. Okay, to this port, and then this port is blocked actually, so we don't have, it cannot receive to the switch, and the switch is going to send the packets to the switch 1, and the switch 1 going to send the MAC address to the laptop 0 here. This is the process of the first thing ever, okay, in a switch when the MAC address is empty. Okay, so as you can see that the process is working just fine, and the ping is going to work like this also. So like in the normal span tree, when I do the ping, alright, ping 10.0.10.200, it is the IP address of the laptop 1. I want to verify a little bit. 1.200. Okay, correct. Actually, it's 1. Alright, so you can see the ping working just fine. So right now, what to do is that I'm going to go to every switches and disable the spanning tree. And what's happened? Okay, so no span tree VLAN 1 like this. So I already have the VLAN 1 inside, so you know, just ignore other VLANs. There's only VLAN 1 here. Okay. No span 3 VLAN 1 here. So you can see that after doing this, you know, every port is going to forwarding states. You can add this port before it's in the orange color. Right now is green. So every port is state. So you guys must see, hey, it is going to be perfect. You know, the speed going to it's going to be faster than before because every port is forwarding. No, you are wrong. Actually, like it's going to work like this. For example, like laptop 1 going to send the packet to laptop. I'm sorry, laptop 0 going to send a packet to laptop 1 like this, and then going to what you do is going to send the packet to the switch 1 here. The switch 1 going to broadcast. First of all, got broadcast to the switch 0. Okay, here we go, like this. Okay, so before this one is blocked, right? This one before this one is blocked, but right now it can forward. What happened is that the switch here is going to send to the laptop 1, and the switch here also send to the switch 1 to switch 0. Okay, and at a time during the transmit, okay, for example, like during the transmit here, maybe transmit at the half like this, not yet arrived to the switch 0. The switch 0 is going to send, you know, to the switch 3, and then the process is going to work like loop like this, you see, and it becomes the broadcast storm here. Let's make your network become slower until we got no bandwidth, no speed in the network. All right, so right now I'm going to trying to ping from the laptop 1 to laptop 0 to laptop 1. Okay, so you can see that the ping, it doesn't work because of what? Because of loop. Okay, loop. We got loop in the production network right now because there's no span 3 on the layer 2 is a switch. Okay, you can see the first one is timeout. The second one we got the packet. The third one also got the packet, and the fourth one you can see is timeout. I'm gonna ping again to make sure. Okay. First time is gonna request timeout because the loop. Yeah, timeout again. You know, timeout again. Okay, sometimes we get the packet, sometimes it doesn't. Okay, so this is the problem. So what we need to do is that we have to add the ball back. Span 3 VLAN 1. Okay, span 3 VLAN 1 and span 3 VLAN 1. Okay, right now I add the ball the span 3 back, and let's see, the packet is working just fine. I get ping from my destination. Okay, this is the concept of the span 3. Hope you guys enjoyed this video, and thank you very much.